As you can see, this is a really bad decision. So why does the brain carry it out? How do the billions of neurons in the brain form complex circuits that allow us to perceive the world, control our activities and bodies, and make decisions? It has been predicted that in the 21st century, mankind will solve the last mystery of the brain. And in the last 2 years, brain tech has become an important pathway to study the brain. With AI, deep learning, and quantitative analysis of brain activity at its core, allowing humans to understand the brain in great depth, guiding the diagnosis of brain diseases, and a more cutting-edge exploration. Today, I'll have an interview with Professor Mina Teicher to explore more mystery world of brain tech. Professor Mina Teicher is the director of the Max Planck Society ENI Institute in Germany, the chair of the International Research and Development Committee in Israel. During her tenure as the chief scientist at the Israeli Ministry of Science and Technology, she led the creation of the world's largest brain tumor database, which uses artificial intelligence to accurately determine the progression of tumors in the brain. She also led the team to use a variety of analytical tools to pinpoint the epileptic region of the brain, pioneering the field. Hello, Professor Mina, how are you? To start today's topic, could you please tell me with the language I may understand, what are the scientists like you doing with brain tech?
You know that we know nothing about the brain. We are using the brain all the time when we don't understand. If you look at the baby, when he's born, he knows nothing. And after 1 year, he has so much knowledge and his neurons are developed and synapses are developed. So all this mystery, it's a mystery because the brain is in a box that we cannot get in so easily. And there is no, like for the blood, there is a blood test. You know, you take blood test, you know a lot about the blood. There is no blood test for the brain. So the imaging is and even if we do it, we don't know the mathematical rules. How does the brain work? What is the system in the brain? Which neuron is talking to which neuron? When I say ma, and then I say there. So you hear ma and there, and you think of the woman that gave birth to you. So this kind of synfire, this kind of a group that hears something and put it together to a concept, you know, to emotion, to cognitive issues is fascinating, and there are no answers. We know very little about the brain. I want to understand how does the brain work. What is the mathematical model of the brain?
Because you just mentioned mathematics, I know you are a very successful mathematician. So I'm just wondering, like, what kind of role mathematics is playing in your research?
The brain cannot be understood without mathematics. For many years, people thought that understand the brain is biology, maybe psychology, maybe medicine. Understanding the brain is a very interdisciplinary task. Many people, many professions need to come together in order to understand the brain. And mathematics is a major tool. So once I was fascinated, when I came with my mathematical tools, I made a big difference. So I really proved the way the brain is working different than what biology thought for many years. It's not only about firing rate, it's about synchronization. So, and I'm using mathematical method not only to understand how does the brain work, but also for medical reasons, to find the epileptic focus in the brain before surgery, to analyze brain tumor, how brain tumors if they are growing or not growing, much better with our techniques and machine learning, much better than what doctors could see in their eyes. And many other places. Mathematics is everywhere, but the brain will not be understood without mathematics.
The brain may be mysterious, but our exploration has not stopped there. Kaha laying the foundation for modern neuroscience in the 19th century to today. Brain scientists from all over the world have set off a multidisciplinary cross-section of research in big data, network science and neuroscience. Mina's team is using data analysis and visual recognition to assist in the treatment of epilepsy. Epilepsy is one of the world's first recognized conditions and has been feared, misunderstood, discriminated against, and even socially stigmatized for centuries. However, it is estimated that 50 million people worldwide suffer from varying degrees of epilepsy, and the occasional mild convulsion or migraine we may experience can be a precursor to epilepsy. Today, a new technology revolution is taking place in this field.
Epilepsy, there's 1% of the population, at least 1% of the population in the world is suffering from some level of epilepsy. So we don't really understand how spread it is, because some people are very mild. They sit in front of you and suddenly for 20 seconds they disappear. And you think that you are a boring person. That's why they think about something else. But in fact, they had a very small epileptic attack. So, and sometimes it's really totally destroy your life if the seizures are strong. And often you cannot drive, you cannot walk, you are like a very disabled person. So when the medicine are not helping to these very strong cases, which 30% of the patient, the medicine is not helpful. So when you take off, when medicine not helpful, you want to go into the brain and make an operation and take out the piece which causes the seizures. So you want, when you go into the brain, to take out as little as possible, because you don't want to sabotage on the way cognitive procedures or motoric procedures. Our techniques is much more precise because we taught the machine with machine learning to look at many, we have a big database to look on many fMRI photos of brain with the data that it was growing or not growing. And the machine is learning to analyze by itself, and it's much better results than in the eyes of the doctor. So our techniques, that using 3 different techniques to localize the epileptic focus, is extremely successful. It has been used in operations in United States, in Israel, and now we are hoping they are going to use it in the United Arab Emirates. So this is an extremely precise method.
Mina leads a team that has set up joint epilepsy research centers with several hospitals. At the time of admission, detection electrodes are pre-planted directly inside the patient's brain, close to the cortex, to collect precise data. The patient's brain is then pinpointed to the epileptic region with the help of genetic algorithms, wavelet analysis, neural networks, and other data analysis tools, thus minimizing damage to the patient. So I know that in the study of human brain, there are many different methods. I've heard things such as MRI, CT, EEG, surgery, and some other kind of methods. So just wondering, what are the methods your research team is using, and what kind of input you have to do in order to use these kind of technologies, and what kind of output you've already, the results you get out of it?
I'm using most of the imaging techniques that you mentioned. So I'm using EEG, I'm using EMG, I'm using functional MRI, and the most advanced one that I'm using is MEG, MEG. It's a very new device that is detecting and recording the magnetic field induced by the electrical activity of the brain. The EEG is measuring electrical activity. MEG measuring magnetic fields. And this is very refined and very expensive device. There are only 40 like this in the world.
You just introduced how the brain tech could be used in diagnosis of those diseases. But aside from that, what it could be like doing in the part of drug development or the treatment for those patients?
Brain tech is not only about diagnosis, it's also about solving. Because if we diagnose where is the epileptic focus, then you can have an operation. Without it, you cannot have it. If we analyze that the brain tumor is growing, then you need different. So it goes together. Analysis goes together with solving the problem.
Okay, so for example, if it's in an operation, what the brain tech can be used during the operation?
We analyze where it is, where is the exact place. But during the operation, usually there are no attacks of epilepsy. So it's not exactly during the operation, but it's just before the operation. For example, these epilepsy operations. So there are epilepsy operations in thousands of hospitals all over the world. So some of them are using our techniques, but you don't see it. It's not I don't have a product to the market now because it's mainly for doctors. For now, we are not developing something that you can buy in the store. It's for doctors, for labs that are doing artificial arms, so it's for motoric and for sleep disorder, epilepsy. So this is behind the scene.
If the treatment of epilepsy is still limited to professional discussion and is something that happens behind the scenes, there is one piece of research that can repeatedly broken the circle and become the hottest topic in the brain science: the brain-computer interface. In late August 2020, Elon Musk used 3 little pigs to demonstrate a functioning brain-computer interface chip and an automated implantation device. The experimental pigs implanted with the chips showed the world that neural signals can be read and written. And in February 2021, they connected the chips to the brains of monkeys, thus enabled them to control a game of ping pong by thought. Musk said, "If it goes well, we'll do initial human trials." The news was met with cheers of technology and business, but also with panic and concern about whose responsibility it is when machines control the human body and cause harm. This is the moral and ethical question that has to be faced.
That people are doing everywhere. So once they're doing it for pigs, they think that at some point they can do it for humans. So that's why it's a bit frightening, but it's also important that he uses it on pigs whose brain is quite developed. Pig has a quite developed brain. When we do research, we do sometimes research on very small fish because we want to understand the activation of neurons, we want to understand vision, etc. So very simple fish we can do that. I have a student that does a fantastic work on that, ex-student. But when it comes to more advanced animals like monkeys and pigs, this could help us more about understanding human brain, because the monkey's brain is very similar to human brain. The first research that I did that really was a counterexample to all what biology thought about firing rate, this discovery of synchronization, we did on monkeys. And we taught monkeys to draw, to make drawings. And when they were making drawings, in the same time that we electronically recorded what they are doing, and we recorded using microelectrodes into their brain, we recorded the brain activity in the same time. And then we could compare. This is, of course, experiment that you cannot do on humans, because humans will not volunteer to get microelectrode into the brain, even though it's not painful, because there are no sensation cells in those areas. So, but nevertheless, we did it on monkeys, or he did it on pigs. It's part of the international effort. Of course, when he does it, it comes to the newspaper. When other people are doing it, they're doing it quietly till they have a properly working device. Let me tell you another story concerning activating paralyzed people. There was this teacher. This appears in my Nature paper about ethics. There is a teacher that was paralyzed in his hand. And always he was very sorry that he could teach, but he couldn't shake the hand of the students in the end of the year. So at some point, he got an artificial arm. And this is like a brain-machine interface. When he was thinking about raising the arm, there was an electrical vibe into the artificial arm, and he could move the hand. Also, he could shake the hand, which is very difficult because shaking is not only reaching, it's also grasping, and there are many fingers involved. So at the end of the year, he was very happy. In the ceremony, he could do that. But now, he doesn't, he shakes the hand of everybody. The last student that came is a student that used to laugh on him on his disability. So when he was shaking her hand, artificial hand, the hand didn't release, and he kept shaking it, and the hand of the student broke. And this is very difficult because there are a lot of small fingers. Yeah. So now the ethical question, whose fault it is? It's the fault of the teacher. It's the fault of the neurophysiologist that arranged it. It's the fault of the engineer that did the hand.
Yes. So except regulations, what like you can do or people can do to like make it more safer for the whole world, just in the aspect of ethics?
Yeah, this of course we have to prepare. We have to prepare a very strong and wide list of regulations. We have to make sure how we can enforce it. So, of course, there is ethics of scientists and ethics of companies, but I'm worried that the personal ethics is not enough. And the desire of people to invent new things and to manipulate other people, you can manipulate people, manipulate organizations, is stronger than their own, it might be stronger than their own ethics. So we have to create rules that are enforced. And and what we are doing now in this group that I told you about, we're trying to go from one government to another. Brain-machine interface, it's a two-way traffic. It's not only you giving information to the machine is also bringing information to you. And this sometimes is very dangerous. But brain-machine interface is the one that allows a paralyzed person to move his hand. So it is extremely important, but we have to be very, very careful about the ethical issues. Because if the brain is producing some kind of a command to the artificial hand, can the artificial hand do worse and put information that we don't want? Can the brain machine manipulate human brain? And this, we have to be very careful. I'm a member of a big group in the United States that is doing the ethical issue of brain machine.
Exactly. That actually you just answered the question I was going to ask. So because this technology, it just reminds me of like Avatar. So you already answered. So there's a possibility that the output signal could control like artificial body, but one day would it be possible it can control a real human body? Would that be possible?
Yeah. Possible, yeah, that could be. And this is something that I worry a lot about. That doesn't mean that we are not doing a lot of advancing science. I mean, we're advancing science, but we have to be careful and clever how to prevent it. You see, science is advancing much quicker than legal system. So if we want to make a new law that it takes a long time, and these clever guys in my lab are doing a lot of stuff in the and all over the world. So this is something that humanity should worry about. You don't want to install memories to someone which he didn't have. You don't want to change his political view to make him vote that way or another. There are many ways that
too
it
dangerous
can
to
be
the world. Yeah.
malused, many ways, yes.
Well, that sounds really science fiction to me. Yeah. Okay, that's amazing. Yeah. And I just want to talk a little bit about our brain because, to people like myself, I always want to be like more clever, to be a genius. But we all know genius is more like they're born with some talent that is better than other person in some kind of certain fields. So with the brain tech, is it possible to use some technology to make people more clever, to make them like a genius? Is that possible?
Well, you are going too far.
Too far, okay. So not now, but in the future,
there is something. Yeah. I never thought about it seriously because I thought that cannot be. But there is something, because your cognitive capabilities not depending so much on your number of neurons, which is 10 to the 10 at most people. It's the numbers of connections, synapse, and the connection between the neurons. That's what makes you function. And the connections are increasing during your first years of life. So if you can somehow increase, but that's like more stimulation to the babies, more as the babies should be exposed to many things. And even when the mother is pregnant, you can start developing more synapse.
What is the end goal? Like, what's the final goal we want to achieve in brain tech? And how far away we are from this goal?
We are far away from that. I mean, we want to be able to help all the issues with the brain. We want to have the robotics and AI that are helping us. So there are so many missions all over the spectrum, from medicine to robotics to industry to finance. So we are really full of angles. There is no one angle, full of angles, and it will take time till we do. But I'm sure that already 5 years from now, we will be in a different position. But maybe 15 years from now, we will have machines that are very capable to do and think for us.
Thanks.
Yeah.
Thank you very much, Professor.
Thank you. It was nice to meet you.
Yeah, nice to meet you. The conversation with Professor Mina Teicher opened up new insights into brain science for me. Professor also told me that mathematicians and artificial intelligence experts like her, they're continuing work on demystifying our brains and exploring more possibilities. I believe that one day our brains will no longer be a mystery, and that in the near future, people with Alzheimer's disease will regain their memories. People with epilepsy will no longer tremble, and people with disabilities will be able to move around freely. I really look forward to that day.